Good. Now, if you see in last session, we have seen how to convert from string to any primitive type and from any primitive type to strings, right? Now, what we have to do is we have to start up with understanding object-oriented concept and then how actually we can use object-oriented concept in order to write programs in Java. That is what is our objective, right? We'll start using Eclipse now, okay? And we have to download certain plugins and all, which we will do in next session in order to ensure that our Eclipse is set up to write application of any type, right? Okay. Now, when we talk about programming is definitely a collection of instructions. But what should be our approach in order to write applications so that we get maximum benefit? Okay. So there were thinkers who were always thinking that how actually program should be written, in what way program should be aligned, in what way program should be designed so that we can get best possible application, right? So in the same line, you have different methodologies which came up in order to help you in writing applications. One of them was procedure oriented. Now, when we say procedure oriented, it means you have to truncate or you have to divide one big task into small tasks, right? And each task has to be represented using a function or using a module, okay? Right? So depending on language that you are using, right? So here what we can say is each problem is divided into small tasks, and each task is represented as a function. Right? So this is what is procedure oriented. Now, if I ask you how you will measure that which procedure oriented program is better, okay? Because you will also write program following the same methodology, and I will also write probably program following the same methodology. Now, how you will make out that which procedure oriented program is better than other? Okay, fine. So in order to ensure that you are able to write best procedure oriented program, you have to take care of two important aspects. One is module coupling, and second is module cohesion, right? These two things are there. Shalini, have you heard it? Heard about it? Eileen? Vidya? Okay. No. See, when it comes to module coupling, it is dependency of one module, or you say function, over other. This is what is module coupling. And cohesion is independence of module. Now, if I ask you that if I want to write a reusable program, or if I want to write a module which is independent of others, right? I have to always look for what? More cohesion, right? So you say higher is the cohesion and lower is the coupling, better is the program. Is that clear? So if someone is asking you which program is better, you can say, right, better program will always have lower modeling or coupling, right, and higher cohesion. Is that clear? Okay, fine. But if you see procedure-oriented approach, you can never have zero coupling. Okay, coupling can never be zero in procedure-oriented approach. It means you can never get 100% reusability in procedure-oriented approach. Okay, is that clear? Some or other change is required if you want to use a function inside your function, right? So what is first problem that was associated with procedure-oriented program? Not 100% reusable, right? Is that clear? Now, why it is not 100% reusable? That you can make out by saying that module coupling can never be zero, right? And if module coupling is not zero, it means there is some dependency, right? Is that clear? Now, there were other problems also associated with procedure-oriented program, and that was global variable. Now, what is global variable? A variable which is accessible everywhere in all functions, right, in the current program. Fine, you have advantage, but you have a very big disadvantage associated with that. And what is that? In case if you are making some error in one of the modules, and that variable is a global variable, it gets circulated to all other modules, right? And it is difficult to go and debug it. Why? Because you have to go and now audit each and every method there. Okay, right? Not good to have, right? Because in case of errors, debugging may be difficult. Right? Is that clear? Fine. Now, third disadvantage which is associated with procedure-oriented approaches, it is more procedure-centric. Means you just think about how to get the output, right? So if it is procedure-centric, you end up ignoring data, right? And data is most important part of the program, right? If you are ignoring that, you may face some issues later, right? So instead of being procedure centric, why not to be data centric? Instead of going with global variable, why can't we have an approach where we can restrict usage of global variable? And why can't we go and do something so that module coupling can be maximized? Okay, and you can get 100% reusable. Is that clear? Clear, right? So now a system was required which can eliminate all these issues or all these problems. Okay, and thinkers started thinking again what should be done, and finally they came up with something called as OOPS, right? Okay, solution to all this was what? Object oriented approach. Okay, so when we talk about object oriented approach, what are the benefits of object oriented approach now? Can you tell me? Whatever is disadvantage of procedure oriented. That becomes advantage of object oriented systems. Okay, right? So all these problems are taken care in something called as object oriented programming systems, right? Which you get as a result of OOAD, that is object oriented analysis and design, where you think in terms of objects. It's clear? Fine. So objective of object oriented is clear, right? What is objective? To do something so that you get 100% reusability, right? It's clear. To do something so that you can come up with a system where you can avoid global variables to eliminate the debugging challenge, and then it's more data centric approach rather than procedure centric. Is that clear? Fine. Now, when actually object oriented analysis and design approach came up, you had many thinkers actually, and there was many approach of doing object oriented analysis and design. For example, you had Grady Booch. Have you heard about him? Then you have Jacobson. Then you have Ramberg. Plus many. Okay? Right? So this industry actually was over flooded with different ideologies, different approach of coming up with object oriented analysis and design. The industry got confused. Whose approach need to be adopted? Right? As a result of which there was a company called as Rational. Rational employed Grady Booch, Jacobson, Ramberg, and they gave them a task. And the task was to come up with common approach of OOAD. Okay? Rational employed Grady Booch, Jacobson, Ramberg, and others, and they said that why can't you all can come up with a standard so that industry can adopt it. Okay? You have to sit together, you have to decide whose analysis is better, whose design is better, and try to come up with a system which can be applied in industry. Okay? As a result of which something called as UML came. Okay? This UML provided a standard. Okay? Standard approach of object oriented analysis and design. Is that clear what is UML now? Right. Later this UML was donated to W3C. Right. The standards are maintained by W3C. It's a body, standard making body, maintains standard of UML. Is that clear now? Fine. If this is clear, if you see there are different approach of talking about object oriented analysis and design. What I will do now is I will talk from perspective of what? Developer. Okay. So for me, what actually approach I will use in order to just go and directly start writing programs when it comes to applying object oriented analysis and design. Is that clear? Fine. So we'll start. Just give me 1 minute and get a coffee and then we'll start. 2 minutes I will just come. Okay. Am I audible now? You're able to hear me, right? Okay, fine. So I was talking about as a Java developer, now what I need to know, what should be my approach in order to think about object-oriented analysis and design. Okay, let's start the steps that we have to follow. See, first step, identify object. Okay, now when you identify object, you have to do it within perspective of system. So whatever system you are going to design, you have to identify object within perspective of that particular system, right? For example, if I talk about a banking system, there I will not talk about doctor, I will not talk about patients, right? I will talk about account, I will talk about transactions, right? I will talk about fund, right? So we have to ensure that we are identifying objects depending on the system, right? So you need to have a boundary for that system and you have to always think within that particular boundary, right? So this is what is first step. Once you identify object, for each object, you have to do the following task, okay? Identify attributes, right? See, objects will have some set of attributes. Without attributes, you cannot go and identify object, right? If I say two students, you will not be able to identify the object, right? But if I say student whose roll number is this or whose name is this, you'll be able to identify the instance, right? And attributes are of four types. When we talk about objects, those attributes will be of four types. First is single value, right? For example, employee ID, salary, all these are what? Single value, right? These attributes will have one value. Then you have multi-valued attributes. For example, phone numbers. I'm taking here phone numbers. Now this is an array, right? String array. This is multi-valued. This attribute can have more than one value. Okay. Then you have third one, which is derived. When I say derived, if I know your date of birth, I can find out age, right? So age is also an attribute. Date of birth is also an attribute. Why to have both an attribute if I can go and if I can calculate, if I can find out, right? What is the age once I know date of birth, right? So those attributes which can be manipulated from existing attributes are called as what? Derived attributes. Is that clear? Now fourth one is composite attributes. For example, you have an object called as an employee, and employee resides at a particular address. The address has its own attributes like city, zip code and all, right? And employee has its own attribute, but address is an attribute which is composed in your EMP, right? So address is an attribute of employee, but address has its own attribute. So these type of attributes are called as what? Composite attributes. Is that clear? It's clear, right? Eileen, is that clear? Okay, fine. Now, once you have identified attributes, you see you have to start creating artifacts also, right? So after identifying object, what you will do in Java? You will go and create a class. You'll give a name to the class. Right? You'll specify the boundary of the class. And once you have identified attributes, you will go and populate this class with those attributes. For example, here you will have empid, you will have salary, right? You need to ensure that each and every attribute is associated with a type, data type. A single valued most of the time are primitive data types. Now here I'll take some multi-valued also. So I'm taking string, array, phone numbers. This is multi-valued, right? I need not take derived because we can calculate it once we have date of birth, right? Composite, address, right? And this address itself will be a class. Right, where you'll have city and zip and attributes of address. So if you see now, your class is ready once you have identified the attributes. Okay. So out of them, how many are single valued? How many are single valued? Employee ID, salary, these are single valued, right? String phone number is multi-valued, right? Address is composite, and date of birth is there from which you can derive age. Okay, so all these are there. Fine. You have identified attributes. After identifying attributes, your next task is to go and identify behavior. Okay, in short, from developer's perspective, methods. Right? Now, actually, when you are doing this, when you are identifying attributes or when you are identifying behavior, you are implementing one very important feature of object-oriented systems, and that feature is what is called as abstraction. Okay, right? So you are doing what here? Data abstraction, right? Because what is data abstraction according to you? It's classifying important attributes, right? Within perspective of the system, within boundary of the system. Is this clear? This is what is data abstraction. One of the important pillars of object-oriented systems, right? Is that clear? What is data abstraction is clear now, right? Either you say classifying important attributes or you say eliminating unnecessary attributes or details. Both are abstraction. Okay, fine. Now when you identify behavior, objective of behavior is to help you in identifying those operations which actually have impact on objects. Okay. For example, you can classify behaviors into following types actually. Once you understand this, it will be easy. First one is construction behavior. Okay. First type of behavior is what? Construction behavior. When I say construction behavior, it means how object must be created. and initialized, right? So how object must be created and initialized. This is what is first thing that you need to keep track of. Okay.
Hello. Hello.
Am I audible? Okay, fine. So I hope that you understood what I spoke. I don't know when I got this. This is the reason why I asked you to keep on prompting. Okay, fine. So I was talking about these behaviors: constructor behavior, then destructor. Then I spoke about accessor. I spoke about mutator, right? Modifiers. All these are what? These are behaviors which get applied on what? They get applied on the attributes of your class that you have identified. Okay? Is that clear? It means what you are doing here is you are not only identifying attributes here, you are also identifying their behavior. So you see, this is what is attribute, and for them you are identifying behavior here, right? And you'll keep all these behavior within the boundary of the class itself. It means now your class will have what? Your class will not only have attributes here, but it will also have what? Behavior. And these behaviors will be specified in form of methods. Right? And those methods are typically called as constructors, then you have getters, and you have setters, right? No destructor in Java because Java does what? Automatic garbage collection. Is that clear? And when you keep attributes and behavior which gets applied on those attributes together, we call it as encapsulation. Okay? So now we reach to second important attribute, second important object-oriented feature. What is that? Encapsulation. Okay? Right. So now you are aware about data abstraction, you are aware about encapsulation. Right? Data and behavior that gets applied on that particular data are specified within the same boundary, within the same structure. This is what is called as encapsulation. Right? Encapsulation provides you an additional benefit, and that benefit is what? It helps you to hide these attributes from external world. Right? It says, so you make it normally private, you make this private, and you provide access to those attributes from where? Using these behaviors. Okay? Right? So these behaviors will provide actually access. Right? It's clear, right? These are public. It means direct access to variables must be restricted. Okay? Direct access to this is restricted. If you want access to attributes, you have to go and you have to get access using behavior. Like you want to get the value, instead of directly accessing employee ID, you have to go and use the corresponding getter method. Okay? Is that clear? Fine. Now if you see your Eclipse follows the same methodology. Means I can create a class in 1 minute following the same approach in Eclipse, because Eclipse provides me the tool. What I am doing is I am just going and closing that. I'll create a simple Java project here. File, new. Just go and create simple Java project. and I'll write here test project. Click on next, right? Click on finish. Click on yes, because I just want Java tools. As told you in last session that we need to select the right perspective. Now what I'll do is I'll go here to test project and see I'm creating a class. I identified an object called employee and now I'm going to create a class, right? Name of the class I'm keeping as employee. Click on finish. Now I'll identify attributes. Let me identify int employee ID, string employee name. Right? As of now, assume that we have identified these. Now you see Eclipse provides you direct support of generating setter and getter. See, right click, go to source, and you have here, right? Generate getter and setters. Select. Okay. Is that clear? Not only this, you can also go and generate constructors. I'm just showing you this. I will discuss in detail. Just telling you this so that you can understand that you can use this productively. Oh, superclass. I'll just go and select it. This is what is one constructor. I can go with other constructors also. So now you have a class ready with all setter getter methods and constructors also, right? Now we will go and we'll create instance. New class, and I'll write a driver class because this is the class where we are going to create instances. I'll just go and write here, like you have created instance of array. Similarly, you can go and write employee emp equal to new employee. Right, this should be correct. Huh? Equal to new control space for employee. You can go and set some value. See, dot set, and you can also set other value. Object is ready. You want to display, you can make call to getter method. So I'll just go and write emp dot get employee name. Right. So this is how you will be creating object. This is how you will be invoking a method by using dot. Is that clear? Fine. Now if I run it, you'll get the value. And so if you see, this is how actually we relate object orientation with Java. It's clear, right? Any confusion? Okay, good. Now, apart from these behaviors which we spoke here, there are other behaviors also. Let me talk about that. See, all methods cannot be just accessor, getter, setter, right? You'll have some methods called as delegate methods or delegate behaviors, right? For example, if I say withdraw fund, right? Now, withdraw fund never means that you will just go and do modification. Withdraw fund means what? You will first go and find out whether amount is sufficient or not, and then only you will be able to withdraw, right? So actually, there are certain methods which are combination of both accessor and modifier, right? Is that clear? So those are called as what? Delegate methods. Is it clear? So all methods will not fit under setter, getter, constructor, and destructor, right? So in those scenarios, what you have to do, you have to go and plan your method, and those methods which are not only accessor or modifier but contain certain correlated logic are called as delegate behavior or delegate methods, right? So now if you see, when we talk about identify an object, it is represented using class, identify attributes of various types, and then go and add it to your class. Then identify behaviors, which are nothing but methods which operates on attributes, and they are of various types. That also you can go and specify inside the class. So since attributes and behavior which goes and manipulates state of those attributes are placed under same boundary, we call it as encapsulation, right? Encapsulation provides you capability of data hiding, because you can go and make all these attributes private, which cannot be accessed outside, right? So it provides you data hiding capability also. Is that clear? Okay, fine. So what I'll do is I will leave you here and no exercise as of now, fine? But material that I have given you is that you have one chapter on object-oriented analysis and design. Please go through it. But as a developer, this is what you need to know when it comes to objects. Yes, we have to go and we have to talk about relationships. See, behavior is any activity that brings some changes to attribute, okay, or that affects or that accesses these attributes are called as behavior. Behaviors are normally represented using methods or functions. Now, for example, when I say fund transfer, it's a behavior, right? So how actually you are going to represent that behavior using method, using IT? It's a function that you will write. So behavior is functionality, either exhibited by the same object in order to access or in order to change attributes, or some other object who is there, who has a responsibility of changing the attributes and all. But any executable statement in Java is always written as a function or a method. Okay, so behavior is something which is represented as a method in your class. Is that clear? Behaviors are of various types. Accessor, that method which goes and accesses value. Modifier, that method which goes and modifies value. Right? Delegate method, those methods which probably use accessor as well as modifier in combination depending on the logic required. Okay? Vidya, is it clear? Fine. So now in next session we will start exploring class, different type of different scopes of variables which we have of class, right? Constructors, how to write constructors, what are the rules that you have to follow when you have to write this special method called as constructors. So as of now, with this note I will leave you. Next session onwards we are going to move to object oriented systems, right? They have to probably dedicate and do more exercises there. Okay.